Hello everyone. Welcome to 4th session of Solar Photovoltaics. This course is presented by B. Escobardan. In previous session we learned about PV cells construction, working, connection of PV cells to form a modules and then to form strings and arrays. In this session you will be learning about solar inverters, covering the topics like basic electrical parameters. What is an inverter? Types of inverters. Types of solar inverters. Main components of solar inverters. Design considerations. Governing standards. Basics of electricity. Current. Current is the rate of flow of electric charge past a point or region. An electric current is said to exist when there is a net flow of electric charge through a region. Current is measured in amperes by instrument called ammeter. Voltage. Voltage is what makes electric charges move. It is the push that causes charges to move in a wire or other electrical conductor. It is measured in volts by multimeter or voltmeter. Power. Electric power is the rate, per unit time, at which electrical energy is transferred by an electric circuit. It is measured in watts by instrument called wattmeter. Resistance. Resistance is an electrical quantity that measures how the device or material reduces the electric current flow through it. The resistance is measured in units of ohms. Direct current DC. Direct current is an electric current that is unidirectional, so the flow of charge is always in the same direction. Alternating current AC. Alternating current is an electric current which periodically reverses direction, in contrast to direct current which flows only in one direction. Power factor, cos phi. The power factor is the ratio between the power that can be used in electric circuit and the power from the result of multiplication between the current and voltage circuit. Types of waveforms. Sine wave. A sine wave is the simplest of all waveforms and contains only a single fundamental frequency and no harmonics or overtones. The sine wave is the simplest waveform. Modified sine waves. When inverters first came out, the most common way to do this was to make the voltage go straight up and down, creating a blocky signal. This is called modified sine wave, seen in red in the image. More advanced modified sine waves make multiple steps, trying to come close to a pure sine wave. Square wave. The square wave is more complex than a sine wave as it contains additional odd harmonic content. When viewed on a waveform graph, it can be seen that the amplitude instantly changes from its minimum to maximum value. There is no smooth transition as seen in the sine wave. The power of each harmonic in the triangle wave is twice as low as their counterparts in the square wave. Thus, the power of the harmonics in the triangle wave is reduced twice as fast as in the square wave. Pulse width modulation. A pulse width modulation signal is a method for generating an analog signal using a digital source. PWM signals are used for a wide variety of control applications. Pulse width modulation uses transistors which switch the DC voltage on and off in a defined sequence to produce the AC output voltage and frequency. Pulse width modulation, PWM, is the most effective means to achieve constant voltage battery charging by switching the solar system controller's power devices. When a battery voltage reaches the regulation set point, the PWM algorithm slowly reduces the charging current to avoid heating and gassing of the battery, yet the charging continues to return the maximum amount of energy to the battery in the shortest time. The result is a higher charging efficiency, rapid recharging, and a healthy battery at full capacity. PWM ensures longer battery life, more battery reserve capacity, greater use of the solar array energy. Inverter. A grid-connected solar inverter converts direct current, DC, from the photovoltaic panels into alternating current, AC, and feeds it into utility grid. How inverter works. Single-phase inverter. In this type of inverter, 4 switches are used. The circuit diagram of full bridge inverter is as shown in figure. Peak voltage is same as the DC supply voltage. The gate pulse for diodes 1 and 2 are same. Both switches are operating at same time. Similarly, diodes 3 and 4 has same gate pulses and operating at same time. But, diodes 1 and 4, vertical arm, never operate at same time. If this happens, then DC voltage source will be short circuit. Three-phase inverter. A three-phase inverter converts a DC input into a three-phase AC output. Its three arms are normally delayed by an angle of 120 degree or 180 degree so as to generate a three-phase AC supply. The figure shows a circuit for a three-phase inverter. It is nothing but three single-phase inverters put across the same DC source. A three-phase inverters are generally used for high-power applications. Block diagram of inverter. DC EMC filter. EMC filters reduce the transfer of electromagnetic noise between the drive and mains power supply. Reduces conducted emission towards the solar panel. These DC filters in PV installations help increase solar panel reliability and immunity in the inverter control phase, avoiding any electromagnetic interference misfunction. 3-phase full bridge. It converts a DC input supply voltage into symmetric AC voltage of desired magnitude and frequency at the output side. LCL filter. A LCL filter is often used to interconnect an inverter to the utility grid in order to filter the harmonics produced by the inverter. AC circuit breaker. DC side of the inverter in photovoltaic systems and other DC systems. MPP, maximum power point, trackers generate disturbances into both the grid's AC power line, as well as the DC side of the solar module. An AC filter is typically used on the grid's AC power line, but the noise generated on the DC side tends to be overlooked. Circuit breaker. A circuit breaker is an electrical switch intended to protect an electrical circuit or device from damage caused by excess current flow or short circuit. Solar farms are just big fields covered with conductive material. Lightning-proof device. They're almost asking for a lightning strike, which can damage or destroy solar panels, inverters, and other critical equipment. Types of inverters. Home inverters or offline inverters. Industrial inverters. Solar inverters. Home inverters or offline inverter. Turned on when mains fails. The offline inverter need not finds its usage often. It is required only when the main power supply fails. Yes, in this case, the electronic device gets power directly from the main AC power supply and not from the inverter. When there is any voltage surge or fluctuation in the main input power, then the offline inverter supplies power to the electronic devices. Therefore, these kinds of inverters are required only during power failures and not all the time. Efficiency of these inverters is less than 65%. Industrial or online inverters. The online inverter is connected to the main load at all the time or until the battery in it gets charged. In this case, our electronic device gets the power from the online inverter and not directly from the AC main supply. So, even when the main AC fails, our electronic device's operations need not be stopped. Efficiency lies in the range of 80 to 90%. Solar inverters. A solar inverter is a type of electrical converter which converts the variable DC output of a photovoltaic solar panel into a utility frequency AC that can be fed into a commercial electrical grid or used by a local, off-grid electrical network. Unlike home inverters, it has built-in MPPT and anti-islanding features. Again, solar inverters are classified into solar off-grid inverter. An off-grid solar-powered system has an assembly of solar panels, charge controller, batteries, and inverter. An existing home inverter can be converted into off-grid inverter by adding a switch to convert source solar or grid. Efficiency of off-grid inverter up to 85%. Solar on-grid inverters. An on-grid solar-powered system has an assembly of solar panels, charge controller, and inverter. Efficiency of on-grid inverters up to 98%. Main components of solar inverter. MOSFET. The MOSFET, metal oxide semiconductor field effect transistor. Transistor is a semiconductor device which is widely used for switching and amplifying electronic signals in the electronic devices. The MOSFET is a three-terminal device such as source, gate, and drain. IGBT. An insulated gate bipolar transistor, IGBT, is a three-terminal power semiconductor device primarily used as an electronic switch which, as it was developed, came to combine high efficiency and fast switching. Snubber capacitors and discharge resistors. Snubber circuits are needed to limit the rate of change in voltage or current and overvoltage during turn on and turn off. A snubber capacitor is a capacitor that is connected to a large current switching node for the purpose of reducing the parasitic inductance of electric wiring. Discharge resistors are used to safely discharge batteries, capacitors, and other voltage-carrying devices. Heatsink with blower fans. Heatsink. A heatsink is a component that increases the heat flow away from a hot device. Blower fans. Blower fans are used wherever flow is needed for exhausting, aspirating, cooling, ventilating, conveying, and so on. Heatsink and blower fans are combinedly used for better thermal management for the switching devices of the inverter so that 99% efficiency can be achieved. DC bus capacitors. The bus capacitor is used in DC to AC inverters to decouple the effects of the inductance from the DC voltage source to the power bridge. LCL filter. A LCL filter is often used to interconnect an inverter to the utility grid in order to filter the harmonics produced by the inverter. DC and AC isolators. These are used between high-voltage DC PV arrays and grid-connect inverters. They are located adjacent to the inverter and are required to provide a means of manually isolating the entire PV array during system installation or any subsequent maintenance. These are required to provide a means of manually isolating the AC supply to a grid-connect inverter. Two AC isolation switches may need to be provided between the inverter and the point of connection to the supply. Gate driver cards. Gate drivers were used to reach sufficient power level. Fuses for DC inputs. A fuse between inverter and the battery will prevent a possible explosion of the battery and it will cut the circuit fast enough to prevent the wires from catching fire or getting dangerously hot. Transformer, only for inverters with transformer isolation. Isolation is required within solar PV inverter systems, primarily because of the high voltages appearing on an AC grid. This can be overcome by using isolation transformers. Isolation transformers reduce power surges. Electrical equipment can run smoothly without the risk of power surges because the DC signals from a power source are isolated. DSP card with communication interface. By DSP-controlled device we can monitor gate signals to IGBT driver cards. MPPT controller. Tracking grid voltage and synchronizing with grid while exporting. Data logging and communication via RS-232/485 protocol. Temperature sensing and operating cabinet and heatsink cooling fans. EMI and EMC filters. EMC filters reduce the transfer of electromagnetic noise between the drive and mains power supply. EMI filters are used to suppress electromagnetic interference, EMI, on signal lines, power lines, or in electronic circuits. Surge protectors. Solar arrays, like all electronic devices, are prone to surges in voltage that can harm components and increase downtime. Surge protection devices can help keep systems running and profitable. Classification of solar inverters. Standalone inverters. Off-grid inverter. Grid-connected inverters or on-grid inverter. Grid interactive solar inverters. Standalone inverter. A standalone solar system. The solar panels are not connected to a grid but instead are used to charge a bank of batteries. Standalone inverter or off-grid inverter is designed for remote standalone application or off-grid power system with battery backup where the inverter draws its DC power from batteries charged by PV array and converts to AC power. Standalone inverters provide variety of size and output waveform depending on your applications. On-grid inverters. On-grid means your solar system is tied to your local utilities grid. Grid-connected inverter or grid-tie inverter is designed specifically for grid-connected application that does not require battery backup system. Grid-connected inverter or grid-tie inverter converts DC power produced by PV array to AC power to supply to electrical appliances and sell excess power back to utility grid. With a range of sizes available in the market, you have to choose best grid-tie inverter to suit your needs, from small residential solar system to large commercial solar system. Grid interactive inverter. Grid interactive inverter is designed for residential, commercial and industry applications. The inverter can operate on both grid-tied and standalone off-grid operations. When utility power is normal, the inverter can operate as grid-tie inverter, which converts DC power generated by PV panels into AC power for supplying to load and feed the excess energy back to utility grid line. When utility power is not available, the inverter can operate as backup power source to supply power from PV panels and battery. Grid interactive system provide clean, reliable backup power in the event of a utility power failure. It can reduce energy consumption and save the utility cost, while maintaining the ability to use the renewable energy source during power outage. On-grid solar inverter types. Central inverter. A central inverter is connected to a series of strings of solar panels rather to just a single string as in the string inverter. In this architecture, the generated DC power from a series of solar panels is connected in parallel with the output from other series of solar panels at a combiner box. The DC output from a combiner box is then connected to a single central inverters. String inverters. A string inverter is connected to a series or string of solar panels. A string inverter is the type most commonly used in home and commercial solar power systems. It is a large box that is often situated some distance away from the solar array. Depending on the size of the installation, there may be more than one string inverter present. Microinverters. A microinverter consists of a small box located on the back of or situated very close to a solar panel. Microinverters monitor the performance of each individual panel. Central inverters centralize the plant's power into one place, while string combiners connect wires from each row of panels together, then recombiners combine the output of the string combiners together to feed into the central inverter. Central inverter units are physically much larger than string inverters, use longer wires and can convert more power per unit. Central inverters are less expensive than string overall for large utility scale installations because fewer are required per site. But for smaller utility scale projects, string inverters could win out for their easier serviceability. Features of on-grid inverters. Maximum power point tracking, MPPT. Inversion function. Anti-islanding. Synchronizing. Remote monitoring. An MPPT, or maximum power point tracker, is an electronic DC to DC converter that optimizes the match between the solar array and the battery bank or utility grid. The MPPT is used to put the panel into a maximum power output stage. Graph shows IV characteristics of MPPT charge controller system. MPPT checks output of PV module. Compares it to battery voltage. Then fixes what is the best power that PV module can produce to charge the battery and converts it to the best voltage to get maximum current into battery. Inversion function. DC is unidirectional, so the flow of charge is always in the same direction. Alternating current is an electric current which periodically reverses direction, in contrast to direct current which flows only in one direction. As the home appliances which we use runs on AC, conversion from DC to AC devices are needed, and inverter is one such device which does this job. Anti-islanding. Anti-islanding protection is a commonly required safety feature which disables PV inverters when the grid enters an island condition. This is an important safety feature built into all Grid Connect inverters. Synchronizing. The power flow between the sources can be illustrated by showing the individual voltage waveforms of the two sources on the same axis. Figure 1 shows the voltage waveforms when they are both in phase. No power flow will result under these conditions. Power flow from the inverter to the grid can be realized if the relative phase of the inverter was adjusted to lead the grid, power export, as in Figure 2. Power flow from the grid to the inverter can be realized if the relative phase of the grid was adjusted to lead the inverter, power import, as in Figure 3, which constitutes battery charging. Remote monitoring. The health of the solar PV systems should be monitored continuously for their better performance and maintenance. For PV systems installed at rural locations, remote monitoring capabilities provide the information in advance when system performance is degraded or is likely to fail. Based on this information, preventive maintenance can be carried out to improve the performance and life of the system, thereby reducing the overall operating cost. DC nominal and maximum power. Nominal power is the nameplate capacity of photovoltaic, PV, devices, such as solar cells, panels, and systems, and is determined by measuring the electric current and voltage in a circuit, while varying the resistance under precisely defined conditions. Maximum power varies with solar radiation, ambient temperature, and solar cell temperature. Efficiency. Solar cell efficiency refers to the portion of energy in the form of sunlight that can be converted via photovoltaics into electricity by the solar cell. Most solar panels are between 15% and 20% efficient. High-quality solar panels can exceed 22% efficiency in some cases. But the majority of photovoltaic panels available are not above 20% efficiency. Total harmonic distortion, THD, is a measurement of the harmonic distortion present in a signal and is defined as the ratio of the sum of the powers of all harmonic components to the power of the fundamental frequency. Harmonic currents generated by PV systems may downgrade the quality of the electrical network and change performance of other electrical equipment. MPPT range. The MPP voltage range denotes the voltage range of an inverter in which the MPP tracker of an inverter can set the maximum power point in order to operate the PV modules at maximum power. Auxiliary power consumption. The power consumed by the solar plant itself referred as auxiliary power consumption. Grid voltage and frequency tolerances. The grid stability is maintained by frequency and voltage control. PV systems can deliver a variable amount of active and reactive power based on the amount demanded from the grid. Indian grid voltage tolerance range is +5% to -5%. Grid frequency is 50 Hz and tolerance range is and/or -3%. Important parameters of inverter. Protection features. Protective relaying is concerned with the redundancy and reliability of the system. The multifunction relays provide a high level of protection at a very attractive cost. The multifunction digital relay can protect a generator from voltage, frequency, reverse power, overcurrent, loss of field, and overexcitation disturbances, while also providing breaker flashover protection. In addition to the above faults and disturbance conditions, loss of synchronism is also protected. Ingress protection, IP, rating. It's a degree of protection provided against the intrusion of solid objects, dust, and water in electrical enclosures. Operating range of temperature. PV panels are generally operated in the range between 15 degrees Celsius and 35 degrees Celsius. As the temperature of the solar panel increases, its output current increases exponentially while the voltage reduced linearly. Standard operating temperature of PV panel is 25 degrees Celsius. Dimensions and weight. Dimensions of panel depends on the wattage of the panel. Technical data of Risharja XTR3 inverter is shown. Electrical characteristics. System. DC input, AC output. Environmental characteristics. Mechanical characteristics. Standards. Countries' standards. Governing standards for inverter. IEC 61683 efficiency of the inverter. IEC 62109 general requirements. IEC 62109 particular requirements for inverters. IEC 62093 MPPT feature of inverter. IEC 60068 environmental testing of inverter. IEC 61727 grid connected inverters. Leading brands. ABB. SMA. Nisal. Growatt. Frenius. Zever Solar. Solis. SimLife. Things Cloud. These are the inverter manufacturing companies. Thank you. For any queries, visit our website www.nirvanafoundation.com.